Chapter 1, Dome Manufacture and Assembly. The materials needed: you'll need steel conduit, 1 inch, 13 10-foot links. You'll need some bolts, 32 inch, 5/16 inch tap bolts, some nuts, 33 of the 5/16 inch lock nuts, some steel corner braces, 3 2.5 inch, some wire, 14 gauge steel picture hanging wire, a little bit more than 10 feet. The tools needed: you'll need a measuring tape, writing utensils such as a Sharpie, metal cutting tool for cutting the steel conduit, we'll be using a chop saw, and a conduit press. You have a variety of options, from our DIY choice to even a hammer. We'll discuss those options later. Drill: we'll be using a drill press. The drill bit will be a 3/8 inch, a wrench 1/2 inch, a ratchet 1/2 inch, and 2 grinders, both for cleaning the rough edges after the cut as well as for cutting. We'll be using 2 different grinders, a belt grinder and a grinder with a cutoff wheel. We're going to have a pair of pliers, and these are going to be used for twisting the wire, and if the pliers don't have a pair of wire cutters on them, you'll need a pair of wire cutters as well. In our previous Horto domi fabrications, we chose a full 2V dome minus the crown, using 1/2 inch steel conduit for all 60 struts. The purpose of the dome was to create an enclosed environment for the bed. There are a number of reasons why I settled on the dome shape. It allowed my growing space to be more circular, which I find to be ideal when concentrating the value of the space, to include nutrient distribution as well as water distribution and retention. And the dome shape also provided an affordable, rigid structure that both withstood elemental pressures such as strong wind and snow, while also doing an exceptional job of maintaining temperature and humidity within the space. There were a number of limitations with this design, however. The low height of the dome made growing fruit plants like tomatoes and peppers a lot more difficult. Also, while accessing the bed was possible, it certainly wasn't convenient or comfortable. In this version, we decided to give the dome approximately 2.5 feet in height using vertical struts. We're also removing 30 struts from the dome's configuration for a number of reasons. This will provide the user with larger ports of access and entry, as well as simplify our outer covering panel manufacturing process, and you'll see more about that in later chapters. Of course, we lost structural rigidity when we removed those 30 struts, and we were forced to make up for it with the rigidity of our material, which is why we moved up from 1/2 inch to 1 inch steel conduit. Step 1A. Wearing the appropriate safety gear for cutting metal, eye protection, hearing protection, safe clothing free of anything that might accidentally want to get cut in a power tool, and gloves. We'll be cutting dome struts, vertical lift struts, and hood support beams now. There'll be 5 different lengths: A struts and B struts for the dome, vertical struts and vertical cross struts for the lift, and hood support beams at the top. To ease in narration, I'll be giving the links in engineer format. I would recommend referencing the supplementary images and diagrams found on hortodomi.com if you're partial to either traditional, standard, or metric measurements. You will be cutting 5 cross struts at 3.26 feet, 10 vertical struts at 2.58 feet, 25 A struts at 2.08 feet, 15 B struts at 1.86 feet, and 5 hood support beams at 0.41 feet. I found that using measurements in engineer's format made any future recalculations or scaling much simpler. You'll need to be economical in cutting in order to use only 13 10-foot lengths. We've placed an image online showing how I cut my lengths, aiming for as least waste as possible. If you position your chop saw in front of a stop and take care not to jostle the saw between cuts, you can perform repetitive cuts of the same length in a fraction of the time. Once the conduit is cut, flatten both ends with a conduit press. There are some ideas to consider when making your conduit press choice. When the struts are assembled, they will bend a number of degrees near where they are flattened. If the conduit has been flattened with a flat edge, the chances of it breaking when it bends are much higher. We have a crescent notch cut in our press and die so that our rounded crimped edges won't break. You could use an arbor press or even a hammer, but our DIY bottle jack in a welded steel box with removable die option only cost us around $100, and that included paying a professional metal fabricator. We've been very happy with it, and it doesn't show any signs of giving out anytime soon. We're going to be crimping the conduit 3/4 of an inch from the end of the pipe to the top of the crimp. You're going to be doing a lot of crimping in this step, and to increase your speed and uniformity, you'll want to make a stop for the conduit. Mark 3/4 of an inch down on a strut ready for crimping, then take a couple feet of wire, bending it centered over the top of the conduit. Slide the conduit into the press and when the 3/4 inch mark is at the top of the crescent, bend the wire around the top die plate of the press. When the conduit is flattened, it's not thinner than the wire, and because of this, it always springs back down when the bottom die is lowered. Both flattened ends must be level with one another. The easiest way we found of achieving this is a complementary level surface, approximately the same height as the press. In our first fabrication, we made a simple stand out of scrap wood. Here in Mike's shop, we've clamped together various scraps of metal to give us the proper height and level. Make sure you only crimp one side of the hood support beams. This step isn't necessary, but if you have the opportunity, we feel it's best to clean up any potentially sharp edges with a grinding surface. We used Mike's DIY belt grinder to clean up both ends of every strut. Wearing the appropriate safety gear, drill a centered 3/8 inch hole in the flattened end of each piece of conduit. The hole should be centered 1/2 inch from each side and 3/4 inches from the top. You can save a lot of time on this step as well with another simple jig. Ours was just a slot, the same size as the flattened end of our conduit, made from scrap wood, properly centered under our drill press. With this, we could simply seat the flattened edge firmly in the slot and get consistent and uniform hole placement. Double check to make sure you have the correct number of each length, that both ends of each strut have been crimped parallel, that any sharp edges have been ground smooth, and that all crimped ends have a center hole drilled. Now we're going to bend the flattened ends of our struts inward a certain number of complementary degrees. We'll be using our conduit press again for this step, closing it just enough so that the flattened end of conduit can be slid between the two plates. You'll be aiming for an 18-degree inward complementary angle on all of your A and B struts, as well as your hood support beams. Don't bother bending your vertical lift struts. This was my first time building this version, and I accidentally did. It worked out fine though. I just had to work against the bends I'd made, bending the struts straight again during assembly. Follow the dome assembly diagram as we build the dome from the top down. Normally I'd build a dome from the bottom up, but since this assembly had vertical lift struts, I thought it'd be easier to handle from the top down. Also, don't forget to orient the hood support beams in the proper direction, uncrimped and directed upward, with a contrasting bend to the other conduit at these intersections. Finger tighten the nuts into place, getting the basic structural form assembled. Then use a wrench and ratchet to fully tighten after assembly. Mike happened to have a pneumatic ratchet, which obviously sped this step up quite a bit. Initially, I thought I would orient the vertical lift strut supports in alternating opposition to one another, my intention being to create more countertension. However, the countertension just caused the base ring to saddle, so I reoriented all the vertical lift cross supports in the same direction, and the dome sat level. Wearing the appropriate safety attire, cut the 3 steel corner braces in half along their 90-degree bend. We used a vise to secure them and a grinder with a cutoff wheel to perform the actual cut. 3 of these 6 halves move forward as part of the dome manufacture chapter, while the other 3 are set aside for the hood manufacture chapter. This step is also unnecessary, but if you have the opportunity, use a grinding surface to clean up those potentially sharp edges. The holes provided in our steel corner braces are smaller than the 5/16 inch bolt we will be sliding them over, so I used the drill press to widen one of the 2 holes in 3 of the brace halves. Using the shield suspension diagram, attach the 3 brace halves to their proper bolts, sandwiching them in place with another lock nut. Tap them down just a bit so they're level with the top of the top ring of conduit. The shield is going to sit on top of the top ring of conduit, as well as this series of suspension wires you're about to run, so try to keep that in mind when leveling the 3 brace halves. Taking the wire, pliers, and wire cutters, if applicable, bend one end of the wire into one of the brace halves, keeping it in place while you run the other end of the wire to its appropriate location, the center of the strut at the opposite point of the pentagon. Take the wire over the conduit and bend it back toward yourself inside the dome. Establish how much extra wire you'll need to feel comfortable twisting tightly, and cut off the excess. Twist both ends of the wire firmly to itself, creating tension on the wire and a reasonable amount of suspension potential without putting so much tension that you stress the wire to a potential breaking point. Repeat this step for the other 2 wires. And that concludes the dome manufacture and assembly portion of this DIY Horto domi instructional.